Good morning everyone. Jai Hind to all. I am Arpita Agarwal, Assistant Professor in CSC Department. Today I am covering Social Media and Analytics and Data Analytics. Code is BCAM 061. So I am taking the Unit 2 today, and the Unit 2 AKTU syllabus are as follows. Graphs and matrices will be covered in Unit 2, and adjacency matrix, paths, connectivity, distance, and BFS, network database, overview of nodes, ties, influencers, making connections, links, analysis, random graphs, and network evaluation, weighted networks, and hypergraph will be covered in the Unit 2 of SMA and DA in AKTU syllabus. So, first of all, what is a graph? Graph is basically a collection of vertices, or we can say it as nodes also, and edges. Edges are the connection between the two nodes, or we can say two vertices. So what are the key components of graphs? Nodes. Nodes are represented by vertices also. So nodes are individual data points or objects, often drawn as circles. Nodes are represented by circles, or we can say it as a vertices also, and it is also used to represent as cities. Edges are represented as by arcs, and edges represent the distance between two nodes. So what the edges represents? Line connecting the vertices, and it basically represents the relationship between the vertices. So what is the degree of nodes? Degree is the edges connected, number of edges connected to the vertex represent the degree of the vertices. So basically what graph represents? Nodes and edges. Nodes represent nodes or entities, and edges represents relationships. So if we use for analysis purpose, we have different types of graphs for analysis purpose. Like first we have a bar graph. So what is a bar graph? Bar graph compares quantities across different categories. So we have studied the graphs in the form of bars. So that represents a bar graph. So description, it is represented by rectangular bars. Height of the bar graph represents values, and categories are on one axis, values on one another as. In this way we represent the bar graph. So what are the different types of bar graphs? Vertical graph, horizontal graph, group graph, and stack graph. So vertical graph is represented in vertical format, horizontal graph is represented in horizontal format. Number of graphs, number of bars grouped together represent in form of group graph, and stack bar graph is the bar represented in form of stack. So what are the example? If we take this bar graph comparing marks of the students in different subjects, if we take the marks of different students for different subjects, then we use the bar graph for representing the marks of the students in different subjects. Next is line graph. So what is the purpose of line graph? Line graph shows trends and changes over a time. So it is basically representation with the help of line. So what is the description of line graph? Data points are connected with a straight line. In line graph, x-axis represent time and y-axis represent numerical values. So if we it's an example, so we know that temperature changes over a week, or we can say stock prices also changes per day, per week. So it is represented basically with the help of line graph. So third is pie chart. So pie chart is a portion or percentage distribution of a whole. So it is represented with the help of pie. So if we go for the description of pie chart, circular graphs are divided into slices. Pie means slices, and graph represented in form of slices is a pie chart. So each slice represents category share of the total. So if we take the total, so each slice represents the category. And what is the use of pie chart? Market share of different companies. So histogram. So what is the purpose of histogram? Frequency distribution of continuous database. If we take a continuous database and represent frequency distribution over it, so it is represented with the help of histogram. So description if we take for histogram is, it is similar to bar graph, but bar graphs touch each other. So bar graphs are represented by rectangular bars. Histogram is similar to bar graph, but bar graphs rectangles are touching each other, but in this histograms, rectangles does not touch each other. Histogram, x-axis shows class intervals, whereas y-axis shows frequency. Like if we use distribution of students' marks or ages, different students have different ages and different marks. So it is represented basically by histogram. So next is scatter plot. So what is the purpose of scatter plot? Scatter plot shows relationship or correlation between two variables. So if we look the description for scatter plot, each point in scatter plot represents a pair of values and no connecting lines. So that represents the scatter plot. So what is the example if we use for scatter plot? Relationship between study hours and exam scores is represented with the help of scatter plot. Next is area graph. So what area graph represents? It represents cumulative data or magnitude over a time. Area graph is similar to line graph, but area graph, in that area is filled and below the under the line. So area graph can represent multiple database. So if we consider the example of area graph, growth of a population over the years is the example of area graph. So next is in the category is bubble chart. So what is the purpose of a bubble chart? When we want to compare 3 or more than 3 variables, then in that case we use bubble chart. So bubble chart is used for comparison of 3 variables at once. So if we go for the description of bubble chart, like scatter plot, bubble size represents a third variable. So if we take the example like for comparing GDP, for comparison of population and for comparison of income of countries, we use bubble chart. So box plot, box and whiskers plot. So purpose, show data distribution and spread. So box plot represent data distribution and data spread. So box plot represents minimum, maximum, medium and quartiles. So how it is useful? It is useful for identifying outliers or noises. So what if we take the examples of box plot, compare text score distributions of different classes. So radar chart. So what is a comparison of radar chart? It compares multiple variables for a string item or group. So description, values plotted on axis starting from center, shape form represent performance. So if we take the example of radar chart, so performance comparison of a student. Performance comparison of a student for different subjects is the example of radar chart, or we can say it as spider chart. So last in the row is Gantt chart. So why Gantt chart is used? We all make projects and we plan the projects and schedule them. So Gantt chart is basically used for project planning and scheduling the project. So if we go for the description of Gantt chart, horizontal bars in green chart represent task and it also shows the start and end time of the activities. So if we take the examples of Gantt chart, like project timelines in engineering or management. So next topic of the unit is adjacency matrix in graph theory. So we all have studies at adjacency matrix in graph theory. So what adjacency matrix represent? Adjacency matrix is basically the metric representation of a graph that shows how vertices are adjacent. Adjacent means connected to each other. So adjacency matrix shows the connection between the vertices of the graph. So if we go for the definition of adjacency matrix, if we have a graph, graph is represented by G, set of vertices and set of edges. When n vertices, adjacency matrix is n cross n matrix, where we can represent adjacency matrix as A, I, J, 1. There, if there is edge between the vertices, it is represented by 1, and if there is no edge between the vertices set, then it is represented by 0. So if we go for the key points for adjacency matrix, rows and columns represent vertices. This is rows and columns. Rows and columns represent vertices. Matrix, if we take the matrix size, it is calculated as number of vertices into number of vertices. So n square is basically the matrix size. So it is used for dense graphs, and adjacency matrix is easy to check if there exists an edge or not. So we go for the example of graphs. First one is directed and second one is undirected graph. Here we are studying as undirected graph. So if there is no direction attached with edges, so we can say that between the two vertices we can go bidirectional. We can go from node A to B, and we can also traverse from B to A. So if there is a bidirectional flow or no direction attached from A to edges, then the graph is called undirected graph. So it is an example, like we have vertices set A, B, C, D. So the graph is represented by like this. So if it is undirected graph, we can go from A to B also and B to A also. We can go from A to C also and C to A also. We can go from B to D also and D to B also. Similarly, we can go for C to D also and D to C also, because no proper direction is attached with edges, and this type of graph is called undirected graph. And if we draw the adjacency matrix of the graph, if their edge is present between the set of vertices, we represent it as 1, and if no edges is present between the set of vertices, it is represented by 0. So if we look from A to A, vertex set, these are vertices set, these are vertices set. So if we look from A to A, there is no set of edges, so we represented it as 0. If we go from A to C, yes, there is an edge. A to C, we represented as 1. We have an edge from A to B also, we represented it as 1. We have edge from B to D, B to D, we represented it as 1. And C to D, C to D, we represent it as 1. Otherwise, there is no edge between A to A, so we represent it as 0. There is no edge between A to D. There is no edge between A to D, so we represent it as 0. Similarly, there is no edge between B to B in the set, so we represent it as 0. Again, B to C, we have no edge, we represent it as 0. B to D, yes, we are having a edge, so we represent it as 1. Similarly, if we look for C to B, there is no edge, we represent it as 0. C to C, no edge, we represent it as 0. Again, D to A, no edge, we represent it as 0. D to D, no edge, we represent it as 0. So if edges is present, then we represent it as 1, and if there is no edge, we represent it as 0. Directed graph. So what are directed graph? If direction is attached with edges, then the graph is represented as directed graph. So if A represents, A is going to B. So direction is attached with edge, that is why we are calling as directed graph. So we can say if there is direction attached to edge, then it is 1, otherwise 0. We cannot represent B to A, because the flow of path is A to B. So B to A will be 0 and here A to B will be 1. So weighted graph. What a weighted graph? If weights are attached to the graph, to the edges, then we can say it as weighted graph. So what we look the, if we look the advantages, so graphs are simple and easy to implement, fast edge look, useful for mathematical analysis, and disadvantages, B.Tech graph uses more memory because n into n, matrix size is n into n, so that it comes out to be n square. So it requires more memory and it is inefficient for sparse matrix. So path in a graphs. So paths in a graph is a sequence of vertices. Sequence of vertices represent a path in the graph. So what is a vertex? V1, V2, V3 up to Vk, V up to n. So it is represented as the path of the graph, means sequence of vertices in a graph. So types of path. So it is a summary for types of path. Different types of path, like we have walk, trail, simple path, cycle, Euler path and Hamiltonian path. And these are the features like vertex repetition, edge repetition, start and end, covers all vertices, cover all edges, and specific condition. So if we come for walk, walk allows vertex repetition. Also walks allows edge repetition. In walk, start and end edge may or may not be same. Walk covers all vertices. No, it is not necessary. Edges cover all vertices. No. There is no special condition in the walk. So if we go for trail, trail also allows vertex repetition. Trail does not allow edge repetition. Start and end vertices may or may not be same. It is not necessary for a trail to cover all vertices. Also, cover all edges is not necessary for a trail. And special condition is there should be no repeated edge. If we go for path or simple path, vertex repetition is not allowed in path. Edge repetition is also not allowed. Start and end vertex is not allowed. Covering all vertex and covering all edges is not required in a path. And special condition, no repeated vertex is allowed in a path, or we can say it as simple path. Simple path means path without a cycle. So what is a cycle? Vertex repetition is not allowed in a cycle. Edge repetition is also not allowed in a cycle. Start and end edge is yes. It covers all vertices and edges. No. And special condition, it has a closed path. Euler path. Euler path, vertex repetition is allowed. Edge repetition is not allowed. Start or end edge may or may not be allowed, but cover all vertices? No. Cover all edges? Yes. Special condition, 0 or 2 odd degree vertices must be there in the Euler path. So if we go for Hamiltonian path, vertex repetition is not allowed again. Edge repetition is allowed. Start and end edge? No. Covers all vertices? Yes. So cover all edges? No. Special condition, it must visit each vertex at least once. So we take the example, it visits every vertex once. So this is the example of walk A to B, A to A, B to A and B to C. If we take the example of trail, so A to B, B to C and C to A. If we take the example of path A to B, B to C. If we take the example of cycle A to B, B to C and C to A. Example of Euler path uses every edge at least once and visits Hamiltonian path visits every vertex once. So this is a summary that we have covered in our previous slide. So walk, vertices and edges may not repeat in walk. Trail, no edge repetition. Path allows no vertex repetition. Cycle is a closed path. Euler path uses every edge at least one. Hamiltonian path visits every vertex once. Connectivity. Connectivity describes how well vertices of a graph are connected to each other. It tells us it is possible to reach one vertex from another using paths. So connectivity is basically, we can say, a way of reaching from one vertex to another is called connectivity. So we have different types of terms used in connectivity, like connected. Connected means path exists between all vertices. Disconnected means no path exists between some vertices. Component, maximal connected subgraph, vertex connectivity, minimum vertex to disconnect, edge connectivity, minimum edges to disconnect, cut vertex. Cut vertex means that if we remove any vertex that makes a graph disconnected, then that vertex is called a cut vertex. Bridge. Edge, like here we remove the vertex, that vertex is called the cut vertex that was making the graph as disconnected. But if we go for bridge, if we remove the edge and that removal of edge disconnects the graph, then that is called a bridge. Distance in a graph. Distance represent how far two vertices are in a graph in terms of number of edges and total path and shortest path between them. So basically distance measures the distance of two vertices. That means how far two vertices are apart from each other in the graph. So next topic is BFS, breadth first search. So breadth first search is a traversal algorithm. So basically it traverses level by level from starting node, then it goes to next level, then to next, and then to next. So breadth first search searches is a traversal algo level by level. So breadth first search is a queue, and in breadth first search we use queue. So basically breadth first search is a graph traversal algorithm that explores nodes level by level. It starts from source, visits all the intermediate neighbors first, then move to next level. So what we take the features of breadth first search, FIFO. FIFO means first in, first out. The person who has entered in the queue first will get his or her reservation booked and will be the first one to get out of the queue. So B4 uses the concept of queue, first in, first out, in data structures. So if we take the example of breadth first search, we have a graph A, B, C, D, E and F. So if we go for traversal algorithm for the graph, so how we will traverse, because we know that we have studied in our previous slide that BFS traverse level by level. So we start from start node, then move to next level and then to next. So BFS traverse will be like this. It will start with start node A, then it will move to B, then it will move to C, then we will move to next level, that is D, then we will cover E, and then it will cover F. So in this way, there will be a traversal of BFS. So if we go for the algorithm steps of BFS, we start from source node. Then if we have visited it, we mark it as visited. Put that in queue. We look that our queue is empty or not. While our queue is not empty, we remove that node, visit the node and add others unvisited node to the neighbors. So this is a pseudocode for the BFS. Like we create an empty queue, mark it as visited. We start to we enqueue it. we will look if queue is empty or not. If queue is not empty, we will add node and equate it, then print node, then we will go for neighbors. If neighbors is not visited, then mark as at visited and add to the queue. So if we go for the time complexity of BFS, time complexity of BFS is vertices plus edges, that is OV plus E, and space complexity of BFS is OV. So what are the applications of BFS? BFS is used to calculate the shortest path, Google Maps, social networking, web crawling, and network broadcasting. So if we go for the differences between BFS and DFS, BFS is basically breadth first search and DFS is depth first search. BFS search level by level and DFS search depth wise. So BFS uses queue, BFS search level by level, and BFS uses shortest path. DFS, while BFS uses queue, DFS uses stack, DFS search depth wise, and DFS provides no guaranteed shortest path solution. So next topic is introduction to network database. So network database is a collection of data that represents a relationship between the objects. It consists of nodes, ties, and influences. So what are nodes or vertices? Nodes are individual objects in a network. Example of nodes: Facebook users, road network cities, computer network computers, and airline networks airport. So example, next example we are looking for A, B, C, D are nodes, or we can say it as a vertices also. Next are ties. Ties are represented by edges. So edges are the connection between the nodes. So example, road between the cities. Edges can be directed and undirected. Directed means if there is direction attached with edges, it is represented by directed graph. And if there is no direction attached with edges, then it is undirected tie. Or we can say it as directed tie or undirected tie. Next is influencers. So influencers are the nodes with many connections. So if we go for the celebrity in the social media with million of followers. So example of a network. So A is connected to B, and A is connected to C. Further, B is connected to D, and B is connected to E, and C has a follower F. So we can say that A has many followers because it has a follower of B. B is a follower of A, and C is a follower of A, and they are sub followers. If we look for B among B and C, B has highest followers because it has 2 followers, while C has only 1 follower. So B is the greatest influencer if we look among B and C, because it has more followers as compared to C. So real world examples of network. Social network, like we have nodes, different peoples, ties are represented by ages, and influencers are represented by celebrities. For a computer network, nodes or vertices are computers, ties are represented by network connection, and influencers are represented by server. Airline network, roles are represented by networks or airports, ties are represented by flights, and influencers are represented by major airport. If we look for road network, nodes are represented by cities, ties are represented by roads, and influencers are represented by major cities. So what is the importance of network? It is used in social media analysis, transportation, internet, disease spread analysis. So if we go for the summary, objects, connections, influencer represent important nodes. Examples: school network, Nodes represent students, ties represent friendship, and influencer represent popular students. So that's all for the today. Thank you.